so here is problem number 1. I'm just going to say for the next few problems, I just want you to find dy dx. So if I said we had this problem. Do you have a volunteer that would like to come up and do this one? All right, come on up.
Oh, you want me to solve it first and then come up?
Your classmates will help you out if needed. You can do it. Why don't you just grab one of those pens and write it up there. Or you can write with your finger if that's neater. So we start, the derivative of 5x to the 7th would be? 35.
X to 6. And that down. 8.
8y to the 3rd.
3y.
Good. Every time you do the derivative of a y, you have to put the dy dx.
0. Guess I could switch this over. So positive.
All right, perfect.
Hey.
Okay, so ask questions as you have them. We've got this little quiz tomorrow, so we want to make sure we know what we're doing. Are there questions on this one? Okay. Let's do another one. So I still want to just find dy dx. Let's say I gave you that and ask for dy dx. Thank you. I'm going to go ahead and get a random number generator pulled up for people that don't want to volunteer.
I don't really want, but I was going to work it out first.
All right, so on the left, what are we going to have to do?
Product.
Yeah.
Okay. What's negative 6 times 7?
42.
Alright, no, I have to do that too.
So derivative of the first times the second plus the first times the derivative of the second. Good, and when you do the derivative of a y, you have to put dy dx.
Is dy dx like a whole number? Or is it like, because sometimes I'd be writing it smaller than like a regular.
Yeah, it's just like a regular number.
Okay.
Same size, not a subscript or anything.
Look at one maybe.
What are we trying to solve for?
The dy dx.
Mm-hmm. So everything that doesn't have a dy dx gets moved over. Bless you. What would we need to do last here? Yeah, can we cancel anything out? Let's look at our numbers first. 48, 42, and 6. What can we... Okay, if we divide each of those numbers by 6. And what about the variables? Do they all have any variable in common?
Yes.
An x. So how many x's could we cancel out? 3. So let's divide everything by 6x cubed. So 48x cubed.
Why can you do that? Because why? How can you do that?
Okay. So another way of saying it is if I looked at the top. If I'm comparing these two terms, we could factor out a 6x to the third. And that would leave us with an 8 plus 7 x to the third y cubed. Is everybody with me there? If we take out the greatest common factor.
Wait, could I not do that if it was a 30?
If, what was?
The 3y like on the bottom.
Okay.
Does that not count, I'm guessing?
So this is all multiplied together, so we really need to go ahead and just multiply those numbers. So the negative 6 times 3 would be what?
18.
Yeah, so we could go ahead and just change the denominator to a negative 18. Everybody with me there? And so then we were just talking about what we could reduce. So now if everything's multiplied, 6 and negative 18 would reduce to a negative 3 on the bottom. 3x's on top, 7 on the bottom will give you 4 on the bottom. And then the top you just have your 8 plus 7x to the third, y to the third. So your answer was equivalent up there. We weren't wrong, but we could just do a little bit to reduce it and clean it up. All right. Questions on that one? And let's look at another problem. So we're slowly getting a little more involved as we go through these. Let's say I asked you to find dy dx if I said this. So who wants to do this?
Yeah. Wait, do you do
What do you got about that?
You know me? I'll do it. But,
Thank you.
But
I'm not good at your functions either, but I knew it was fine.
We'll help you out.
you do the product though right there?
Yes. So essentially, what you have on the left, you have y times the cosine of 3x. On the right, you have x times the sine of 4y. So you have to do the product rule on each side.
You gotta stop me if I'm doing something wrong.
Okay, so derivative of the first
Oh, that's too big.
times the second.
I wrote too big.
It's alright. Plus
And then, okay.
the first times the derivative of the second. What's the derivative of cosine? Negative sine. The angle stays the same. And we have to do times 3, the derivative of that angle.
Oh, shoot.
Gotta have that change.
I always do.
Yeah. Okay, I'm gonna write really small on this one.
You can just go underneath it if you need to. Equals, and then we do the product rule over here. So derivative of the first times the second plus the first times the derivative of the second. Derivative of sine is cosine, angle stays the same, times the derivative of the angle. And since it had a y,
Yeah.
Do you put it to dy dx like
it's like
in
a
the cosine, or is it with the?
it's with the 4. So what this is saying right here, he has x cosine of 4y, and then the derivative of 4y is 4 dy dx. Okay, now we need to try to clean some of this stuff up. So we have more than one dy dx. What does that mean we have to do?
You know, when it's on the side.
Mm-hmm. So which one do you want to move?
I don't know. Move this one.
Okay. So I'll help you space things out. So you're going to keep this one over here. Now, when you multiply that, you could go ahead and put the 4 in front. So it's 4x cosine 4y dy dx.
I don't even know where to start. Just minus this one?
Mm-hmm.
What's that one? Bro, I'm confused.
Both of these have a dy dx, right?
Yeah.
So we need them together. So let's just say if I just move this one over here, you have a dy dx cosine of 3x minus, if I multiply this one, it's a 4x cosine 4y dy dx. Alright, so I brought that one over. So over here, I still have a 1 times that, so that would just be the sine of 4y. And then this was a negative, so if I bring that over, it becomes plus y sine of 3x.
What about that 3?
Oh, yeah, I lost that 3, didn't I? 3y sine of 3x.
And then do you pull out the...
So on the left, factor out dy dx.
Is that the answer?
So we would just rewrite it. So dy dx is sine 4y plus 3y sine 3x over all that. Alright, that is our final answer. So, looks like that one was a little more difficult for us. We have to remember that chain rule when we are doing the derivatives of those trig functions. All right. Questions there?
Are we gonna do one with like the square, a trig function like squared?
Like a second derivative?
Or
Is that what
no, like the ones when it was like tangent squared x or something.
Oh, I mean, I could, but. Okay, let's do a few more of these. So if I said to find the derivative dy dx, if I gave you tangent squared y equals x cubed. Who wants this one? Alright, so big thing to remember when you see this tangent squared, that's saying you have the tangent of 3y all to the second power. So what do you have to do first? Chain rule. So bring down the 2. Derivative of tangent is secant squared. The angle stays the same. We have to keep doing chain rule. Derivative of the inside. What's the derivative of 3y? 3.
No idea.
Mm-hmm. Okay. Equals derivative of x cubed. Alright. So what could we do here?
Just like combine all that.
Mm-hmm. So our coefficients we could pull out in front. We have a 2 times a 3, which would give us a 6. And then what would you do to get dy dx by itself?
Just divide all of it.
Mm-hmm. Is there anything else we can do to finish that?
36.
Yeah, 3 and 6 would reduce, so we get dy dx equals x squared over 2 tangent 3y secant squared 3y. Yes, sir.
So, what if there was like an X before like the tangent or something? Like, how would you like put that?
You'd have to do the product rule. Like you're meaning at the very beginning.
Like, how would you like put it?
So.
Like we did tangent 3y.
You're saying if there was like an X out
Like,
here.
how would you write that?
So you would have to do the product rule when you did the derivative. So derivative of the first times the second plus the first times the derivative
Okay, so
of the
that's
second.
like.
Yeah. Other questions there? Okay, let's do a few more. I want the equation of the tangent line to the curve let's see. Okay. Who wants it? Thank you.
Maybe.
So what do you need to write the equation of a line?
Slope.
Point and a slope. I gave you the point, we've got to get the slope. How do you find the slope? Derivative. So derivative of x squared is 2x. What about the 3xy? What will you have to do? Product rule. So derivative of the first times the second Okay, we have two options. Did I ever ask you specifically what dy dx was? So we can either plug in our point now and then solve for dy dx, or we can get the dy dx by itself and then plug in our point. It doesn't matter. Might be easier to plug it in here, but you'll get the same answer either way. So if we go ahead and plug in, what's our x going to be replaced with? A 1, and y would become 2. Combining all of our like terms. So dy dx is negative 8/7. So that's our slope. Now we plug into y equals mx plus b.
Yeah, a new class, right?
So 2 is like 14/7 plus 8/7 would be 22/7. All right, very nice. want to do one more from section 3.5, and then we'll do a couple problems from section 3.6. Are we okay on this one? All right. Who would like to volunteer for this one? Thank you, Rose. Alright, solve for dy dx. Okay, so everybody okay to this point? So you did the first derivative, find dy dx. Now we need the second derivative, so we do the derivative of that. So we could do the quotient rule here. So low d high, and that'd be a negative 2x, right? Minus high d low over low squared. Okay. So simplify, so we have negative 2xy squared and then we can replace dy dx was one of those y's cancel.
Wouldn't that be just one of the ones?
Yes, so there's still.
Yeah, then you do that.
Okay, now. Yes, we have to clean this up. We don't leave a fraction in a fraction, so if we multiply by y on top and bottom. So we have negative 2xy cubed. All right, in the next term, if we multiply the 2 and the negative, we'll make a minus 2x squared times x squared, the x to the fourth. Now, the only thing, I think we have an extra y here. Oh, sorry. All right, I'm going to try to write for a second. When you multiply everything by y here, okay, or I guess it was really this step, these y's cancel. So there is no y here. That was all one term, so you didn't have to take both pieces. So that is our final answer. Negative 2xy cubed minus 2x to the fourth over y to the fifth. Questions on that one?
So only took one y that cancels out the y squared.
Well, okay. We had a 2x squared y times a negative x over y squared. So one of them canceled there. So that gave us a negative 2x to the third over y. So then it only took one y to cancel that remaining one. Alright. Is that better? Okay, so let's run through a couple of the log problems. So if I asked you to find the derivative of natural log of 5x, I'll do the first one. This will be my contribution. 1 over the argument, but then we have to do chain rule. So times derivative of the inside. What's the derivative of 5x? 5. And so we just get a 1 over x. All right, what if I said you had this one, and I wanted the derivative. All right, Jessel, you want to do this one? Maybe I shouldn't say do you want to. Would you do this one for us? What would we have to do for the first part? The x squared natural log of x.
Right.
Product rule. So derivative of the first times the second plus the first derivative of the second. What's the derivative of natural log? Good. Minus 12x cubed. All right. 2x natural log of x, there's nothing we can do with that, so we're just going to keep that, 2x natural log of x. But what would we do with the x squared times 1 over x?
They could go to the negatives. Or like flip it.
You could write it as an x to the negative 1, which if you multiply those and add your exponents, you get 1, just an x, so an x to the first. Do we have any like terms? Nope, so we're done. Let's do one more. If I gave you
Sorry, you're up. You got it.
this. Do you want it?
Try.
Okay. So the derivative of a log is always 1 over your argument. One over good. Now we have to do the chain rule, so times derivative of the inside. So the okay, we're going to get there, but let's go in order first. The inside here is really all of that. or you could think of it to the 1/3 power. So the first thing you would have to do is bring down the 1/3. Inside stays the same.
yeah.
Subtract 1 from the power. So 1/3 minus 1 would be negative 2/3.
N times
Derivative at the inside.
3.
Alright, so lucky for us, 1/3 times 3, that really cancels. So then what would you do?
Just, that would be x squared times the x3 plus 2 over.
Mm-hmm. Good. You could go one more step. What does a negative power do? Okay, so if we brought that down, then you'd be adding 1/3 plus 2/3 is just 3/3, which is 1. So you just get an x cubed plus 2 to the first on the bottom if you cleaned it up all the way. All right. So I've tried to run through everything from these two sections, like I might ask. I don't have any actual homework for you unless you want me to make up some problems. Otherwise, I would just recommend looking back over these. You know, if you want to study, I would just take the problem, try working it out, and see if you get the same answer we got. We do have a couple minutes, so if there's something else you want a problem like, I could do one more. Just like,
So did you, like the x squared, did you divide it or something? I mean, that's the x.
no. It's still an x squared. Sorry.
So confused.
Other questions? Or anything else you want a problem like?
What about when it's like example 5 on 3.2 or not 3.6 is x plus 1 over the square root of x minus 2. Like something like that.
Was it the natural log of all that?
No, it just says yeah, it is natural log.
Okay, so that's like the problem we worked out at the beginning of class when you asked me to work that one homework problem. So the derivative of a log is 1 over the argument. Times derivative of the inside, and we'd have to do the quotient rule for the derivative of the inside. So low d high, derivative of the top is just 1, minus high d low, so 1/2 comes down, inside stays the same, subtract 1 from the power, derivative of the inside, over low squared. So if you take the square root of x minus 2 squared, you just get x minus 2. So then 1 over this, that's just the reciprocal, so you could flip it. Let's see. Is everybody with me so far? So if we distribute on the top, x minus 2 to the 1/2 times x minus 2 to the 1/2 is just x minus 2. Minus 1/2, x plus 1, x minus 2 to the 1/2 and negative 1/2 would cancel. So a couple things, I need to get rid of this 1/2, so what would we have to do? Multiply everything by 2. So if I do that, we get 2x minus 4. Those would cancel, so minus x minus 1 over 2 times x plus 1, x minus 2. And then you